objects in the sky improved, we realized again and again that the solar system is much larger than previously known. And when I say much larger, what I mean is that we are continuously finding objects that are orbiting the sun from extremely large distances, and even pretty frequently objects that are somewhat big. And that realization as to how vast the solar system is was especially hammered in during the 2000s and onwards, since that's when we started constantly finding objects either beyond Pluto or at about the distance at which Pluto is right now, with roughly about 100 objects found that are even large enough to have enough mass to be spherical. So those are very likely dwarf planets. One significant dwarf planet that was found in 2005 is called Eris, which has a diameter almost exactly the same as that of Pluto, and is actually even significantly more massive than Pluto. And it also has a relatively large moon called Dysnomia that has a diameter of about 750 kilometers, and it is most likely spherical. Eris is, at the moment, one of the most distant objects in the solar system that we know of, at about 95 astronomical units away from the Sun, which means it is nearly at its furthest point in orbit from the Sun. Now, since 1 astronomical unit is equal to the distance between the Sun and the Earth, that means that Eris is currently 95 times further away from the Sun than the Earth is, which means that it is about 2 times further away from the Sun at its most distant point from the Sun than Pluto is at its own most distant point from the Sun. And it also appears 13 hours in the past, since the speed of light needs 13 hours to cross that path between the Sun and Eris. Still, this is not always true for Eris, because it has quite an elongated orbit. It's quite elliptical, which is a feature that nearly all dwarf planets have in the solar system, including many asteroids, comets, and moons, especially when they are orbiting from great distances. Such a highly elliptical orbit means that Eris's distance from the Sun varies to quite a large degree. At its closest to the Sun, it is about 38 AU away from it, and at its most distant, it is 98 AU away from it. So there is a twofold difference in the distance from the Sun between its closest and most distant point away from it. Such elliptical orbits have a shape which causes their distance from the Sun to vary. But on top of that, they are also not centered around the Sun. The Sun is to the side from the center of an elliptical orbit. And the more elliptical the orbit is, the more is the Sun off to the side from the center of an orbit. With regular planets, there is not much of this difference in their most distant and closest point, because their orbits are nearly circular, and circular orbits are almost perfectly centered around the Sun. So the Earth is 147 million kilometers away from the Sun at its closest point, and it is 152 million kilometers away from it at its most distant point. So there is a difference of about 5 million kilometers, which is only a difference of about 3.5% between the closest and most distant point away from the Sun. And also, the more distant the object that is orbiting the Sun, the slower it goes around the Sun. So, Eris orbits the Sun at an average speed of about 3.5 kilometers a second, while the many times closer Earth is going around the Sun at an average speed of about 30 kilometers a second. So the Earth is on average going around the Sun at a speed that is 9 times greater than Eris's speed. So the speed of Eris orbiting and its extremely long orbital path makes Eris need about 560 years to complete a single orbit around the Sun, which is double the amount of time that Pluto needs to complete an orbit around the Sun. Still, there are objects found that are currently much further out than Eris. For example, 2018 AG37, also known as Far Far Out, which is quite an appropriate unofficial name, considering that it is right now at a distance from the Sun of about 130 AU, quite a bit more distant from the Sun than Eris. And far, far out is not just a tiny rock. Based on its visibility, the estimates of its size put it at around 400 kilometers in diameter. Possibly it is quite a bit bigger, meaning that there is a significant chance that it is also spherical. With objects that are right at about 400 kilometers and above in diameter, that is when they have the potential to have enough mass to be spherical. The example of that being Miranda and Mimas. So this means that far, far out is quite possibly a dwarf planet. Now, although we can observe far, far out, because it is so far away from the sun, it moves in its orbit so incredibly slowly as well. And because of that, it is hard at the moment to determine its precise trajectory. So we are not certain as to what its orbit is like because of that. Still, based on its movements observed since 2018, when it was discovered, the estimate is that it is currently at its most distant point in orbit at 130 AU, and that its closest point, it should be at around 27 AU away from the sun, which means that at its closest point, it should be closer to the sun than Neptune. This is because, of course, of its highly eccentric, elongated orbit. Now, by looking at the area of the sun in which it is gravitationally dominant, and that area of one's object is called the Hill sphere, then according to some calculations for the sun, it very approximately extends to nearly 2 light years away from the sun. And that edge, which is nearly 2 light years away from the sun, from the surface of objects that are at that distance, the sun appears almost as just as any other star in the sky. The sun is around 15 billion times fainter compared to the sun from Earth. Whatever objects are at that distance currently, their surfaces are nearly pitch black. So the space at a distance from the sun from 1000 AU to around 100,000 AU is called the Oort cloud. And we actually know of a relatively big object that can be considered as a part of the Oort cloud, an object that is on average further out from the sun than far, far out. And considering how distant it can get from the sun and how large it is, then 2014 FA72 is the most significant distant object at the moment. Based on how much it reflects light, the estimates are that it is around 250 kilometers in diameter, possibly quite a bit larger, which means that this is another object that has the potential of being a dwarf planet. Now, at the moment, 2014 FA72 is 64 AU away from the sun, but based on the 4-year observation,